Good morning, everybody. Today I'll be teaching the part of gas lift system. This is multiple operating valve, and it will include also this intermittent gas lift system, plunger lift system. And let's one by one. Let's see the multiple operating valve. Why multiple operating valve is required? So if you see this problem, you will understand why a multiple operating valve is required. Because I have wellbore, and I can put only one valve to increase productivity, or I can use multiple valves. Okay, so why should we use multiple? I can use only one. What is the issue? Let's see this problem. Assume wellhead pressure and the differential density constant. The gas surface operating pressure is mainly dependent on the position of the interface between gas and liquid. This is the initial assumption. Now operating valve depth 10,000 feet. Okay, this is 10,000 feet operating valve depth, and wellhead pressure is 400 psi. Okay. Now completion fluid density 10 ppg. Completion fluid means initially we are assuming the whole wellbore is filled with completion fluid. Okay. Completion fluid means whatever density is there of completion fluid, whole thing will be acting, and its density is given 10 ppg. So it is given 10 ppg, pounds per gallon. Actually you have to convert to psi per feet. The gas density also given 0.006 ppg or pounds per gallon. So calculate surface operating pressure. So whatever pressure you are injecting from here, so P, so surface operating pressure you have to calculate first. So the one formula we know that PSO equals P wellhead plus 0.052, this is unit conversion factor, rho fluid minus rho gas, density of fluid and density of gas, this minus, and dg. Okay, so if I put the value 400 plus 0.052 into rho f given 10 minus rho g given 0.006 and dg given 10,000. Okay, so this value gives 5600 psi. Okay, but on the surface this much of pressure will not be available, PSO. So what you have to do, you have to put multiple one. So normally this on the surface pressure can be 1500 psi or around 5600 psi. It is very high actually. So what you do, you inject first a valve on the top, nearby top, then you reduce hydrostatic pressure of the column, again you activate next valve, again reduce column, again next valve, again next valve. So in that way you reduce the whole column weight and gradually you start producing, and in that case your PSO or surface operating pressure will not be so high. So available PSI of 1500, then this will not work actually in single valve. So you have to use multiple valves. And whenever you are having multiple valves in wellbore, let's say this one, many valves. So let's say how much time will take to activate this one? 1, 2, 3. So first one you activated. After certain time you have to activate 2, so that flow will get stabilized and all the bubbles will get formed. It will move to the wellhead and your line. Then after that, after certain time you activate 2, again bubbles will be moving and your whole column weight will get reduced, and again it will be stabilized. Then next you activate valve 3, valve 4, in that way. Okay, so API RP, recommended practice 11V5, this says like 10 minutes for each 50 psi increase in casing pressure up to 400 psi. Okay, so in each 10 minutes you increase 50 psi, then 100 psi for every 10 minutes. Okay, so gradually you have to increase, and if you are reaching to 1000 psi, so it will be taking about more than 2 hours. Okay, so slowly you have to one by one you have to activate. You cannot do like valve 1 activated after 2 minutes, valve 2 after 3 minutes. It will not work like that. Okay, so you have to give certain time so that fluid will get stabilized in the tubing and bubbles will be formed. hydrostatic pressure will be reduced. Again you activate next one, again you reduce further hydrostatic pressure, you give certain time to be stabilized, again next one, again next one, again next one. In that way you reduce the hydrostatic pressure. When you are reducing hydrostatic pressure, your PWF, flowing pressure, wellbore flowing pressure, will get reduced, and PR you are not changing, because this is gas lift operation. Gas lift operation, you are not modifying reservoir, you are modifying only the wellbore. If you are modifying reservoir, then actually that will be called enhanced oil recovery technique. So in that case you inject a steam, high pressure steam or high pressure gas also you can inject, and you can modify a reservoir property. Presently artificial lift technique, we are not considering that part. And so whenever we will be asking any question, it will be relevant to your artificial lifting system. Now first valve depth. Okay, so you got a 10,000 feet depth, I already told, like, right, 10,000 feet. Okay, now I said if I have valve here, so 5600 psi pressure is required. Then what should be the first valve depth from top? Okay, so what will be this D, first one, then you have to put second one, you have to put third one. Okay, so you have, for that you have a formula, PKO or kick off pressure, kick off pressure. Okay, so from surface you are applying pressure, so that first valve will be starting bubbling, gas will be injected through the valve, and it will pass through the annular and it will create bubble. So that first instant the pressure required is called kick off pressure, and kick off pressure minus wellhead pressure divided by G rho F, G rho F, and G rho F is actually G, it is expressed as G into rho F. G gravitational constant, you know, rho F fluid density or completion fluid density or kill fluid. Sometime you are killing wellbore because you want to do some operation, after that you again start your production, so they say kill fluid. Okay, so normally this density people will be assuming 0.45 psi per feet, 0.45, 0.5, that one kill fluid density. Okay, just for thumb rule, that it may be different also. So one problem, let's assume wellhead pressure 120 psi, wellhead here pressure is PWH 120 psi, and kick off pressure 700 psi. So you start injecting, so U tubing you are creating. So when first valve will get gas, so that gas pressure will be called kick off pressure, so that pressure is 700 psi. So completion fluid or kill fluid gradient 0.45 they have assumed, sometimes they assume 0.5, that around. Okay, so from this formula, the formula you get 700 minus 120 divided by 0.45, so 1289. Okay, so if you use this formula you can get first valve depth. Now what will be the second valve depth? You go to the next formula. So second valve depth will be dV1, first valve depth, plus kick off pressure for second valve, wellhead pressure, and rho m mixture density. Why mixture density? Because already you injected gas. Initially we assume the kill fluid, purely liquid, there is no gas. Now you injected gas, so it become a mixture of liquid plus gas. Okay, so that density, average density you are putting here, rho m, G gravitational constant, dV1, so first valve depth, and GF again the same parameter you take 0.45 or kill fluid gradient. Okay, the pressure gradient of the mixture and gas completion fluid GM. Okay, if the density is pound per gallon, then okay, so unit conversion factor is given here 0.052. Okay, so whenever you are solving problem, you have to see the unit. If unit is wrong, then actually you will get wrong result. So you better look at the unit and then you convert if required. And you get second valve. Similarly you can get third, fourth valve. So in generalized equation is that dVi plus 1, dVi, Vi plus 1 actually, dVi. So dVi plus PKO minus rho WH GM and dVi divided by GF. and here they are assuming unloading valve I equals 0 and dV0 equals 0. So, first valve is they are assuming 0 as 0 point. So, then you can get all the valves. And one point again, I will be reminding you that when you are activating first valve, second valve, third valve, fourth, fifth, the bottommost valve may not be your operating valve, maybe the before one or two before the bottommost valve can be operating valve, but sometimes the bottommost valve also can be operating valve. So, there is no this is not a specific fixed criteria that bottommost valve will be the operating valve. They put several valves based on their requirement, they can activate, the engineers. This one term comes again and again when you study gas lift system, macaroni installation. Actually, this was a very slim hole, ultra slim hole application, tubing for gas lift application. For ultra slim holes it is used, and casing size they are saying like 2 and 3/8 inch, 2 and 7/8 inch, 3.5 inch. So, within this range casing will be there. So, it is very slim hole actually. So, inside you are putting tubing, so tubing must be much narrower. So, here you can see the tubing size becoming 1 and 1.5 inch. Okay. With gas lift valve installed. So, gas lift valve we have to fix within that. So, everything is very narrow and compact. Smaller tubing is called macaroni tubing. So, that tubing is called macaroni tubing, can have a gas lift valves. Okay. This reduces drilling and completion cost because you have only slim hole and you are injecting gas. Okay, instead of again redrilling or recompleting, you are using this one. Two smaller tubing string also can be running if the casing is a little bit wider. It's a 3.5 inch casing is there. So, 2 1 inch casing also you can try to put there and you can get production. Okay, and why two tubing can be used? Because you want to produce from two different zone. Okay, let us say this is wellbore and I have one tubing here and I have perforated this area, okay, and I have another zone production area, maybe this one for gas, this one may be oil, more gas, more oil, and you want to get from here also. So, from here you get all the gas or oil, gas or oil or whatever, and you put another tubing to get oil and gas from this one, bottom one. Okay. So, you can put multiple tubing to get production. Okay. Small tubing string can be concentric or parallel. So, here I have drawn one parallel system, but sometime it can be concentric, one tube over another tube also possible. So, this is called macaroni installation. These terms are actually good for your competitive exams. Normally in competitive exams they will be giving all these unknown terms. So, you should not say this is not relevant to artificial lifting system. Okay. Now, intermittent, basically we considered all the continuous gas lift system. Now, see the intermittent gas lift system. Intermittent gas lift system, why required? Okay. So, let us say you have gas well deliquefaction. Okay. Gas well means you have lots of very high fluid velocity, and because of very high fluid velocity you are getting mist flow. The liquid, small amount of liquid coming in the gas well, that is creating mist. Okay. So, very tiny particle is being created. Tiny particle created means slip falling back to the wellbore will be very that the velocity will be very low. So, whatever gas velocity there, gas will be carrying this fluid upward. Okay. Fluid means liquid. And if you reduce this liquid fluid velocity or gas velocity, then what will happen? The gas will try to fall back. Okay, at very high velocity gas is going, so the fluid's terminal velocity was downward, it will be lower than upward velocity of gas. So, because of this upward velocity of gas, fluid will be pulled out of the wellbore. Okay. But if you reduce gas velocity, what will happen? If you can remember that one, this fluid particle weight is there and drag is pulling up, right? FD, drag force, and weight is down. If drag force is very high, it will go up. If weight is little bit higher, then actually it will be sliding back. So, first phase is that mist flow, then your reservoir pressure little bit depleted or reduced, then in that case gas velocity will go down. Gas velocity going down means the small liquid particle will try to create bigger particle that will be soaking the wall. Okay, that is called annular flow. Already we discussed actually in multi-phase chapter, but again relook at it relevant to this. Then again you reduce further velocity. So, in that case you create some bubbles also, okay, small tiny particle will create bigger bubbles, okay. Then bigger bubbles again it will be colliding, and when it is colliding it will create slug flow. Again it will be colliding and slowly moving down. Then further collision will occur and gas will try to exit from this slug area, then they will create bubbles. So, when they are creating bubbles, actually liquid will be falling back, it will be stabilizing at the bottom and gas will move off. So, gas will not take the liquid, they will say, hey, you are too heavy, I cannot carry you, just you stay here, I am leaving, okay. So, in gas well deliquification technique, this is the dangerous. So, liquid is falling down at the bottom. Why? Liquid is held up. The term we used, you can remember, held up. Held up at the bottom. Okay. So, liquid is held at the bottom. So, what will happen? So, H rho g. So, you have reservoir, okay, PWF, PR. PR is fixed reservoir pressure and flowing pressure must be reducing. But what happens, because liquid column is growing up, so liquid column is H rho g, H increasing. When H increasing, that means PWF is going to so your flowing pressure is increasing actually. So, flowing pressure increasing, PR certain amount is there, flowing pressure increasing, the difference will be very low, okay. When PWF and PR difference is low or drawdown low, so new fluid will not come into your wellbore, okay. So, in that case your gas or liquid entry into wellbore will be stopped. So, you will not get any production. So, what you have to do, you remove the liquid from the wellbore by any means. If you remove, again PWF or flowing pressure will go down and reservoir pressure is here, fluid pressure gone down. So, difference created, drawdown, higher difference created, again fluid or gas or liquid will enter into wellbore, it will move up, okay. And if you have higher liquid column height, it will be further obstructing this one, and liquid column will not move up to very high level, it will not create very high liquid column, because when flowing pressure, reservoir pressure almost equal, that time fluid or liquid will not enter into wellbore. So, the column height will be limited only, okay. If reservoir pressure increasing because of other means, then maybe liquid column can go up, okay. But in our case, intermittent flow gas lift, what we do? We inject gas to remove this liquid column. If we can remove liquid column, again my flowing pressure will be down, reservoir pressure already fixed, we are not changing here, we are not using any UR technique, we are assuming. So, difference created, again fluid will be entering, you will get more production. So, intermittent gas lift system, so I just shortened it, IGL means intermittent gas lift system. So, IGL used for tubing flow, okay. Packers and standing valve frequently used. So, intermittent gas flow like this one, okay, packer will be there and sometime one valve also will be there, okay, for IGL case. So, it is closed system, you can remember previous lecture we discussed like open, semi open and closed system. So, this is actually closed system, okay. So, casing is here and tubing will be packed properly, a packer will be used and one valve will be there, standing valve, okay. This is called standing valve, standing, okay. This valve is not moving too high distance, only small movement will be there. So, this is called standing valve. A sitting nipple with standing valve may be there. So, sitting nipple will be here, nipple, okay. For high or low BHP with low PI reservoir. So, BHP or bottom hole pressure can be high or low, but PI should be lower, then you are using intermittent. If PI is higher, productivity index is higher, normally you will go for continuous flow gas lift. The flow from a well using intermittent gas lift technique called ballistic or slug flow. Actually, when you are using intermittent flow gas lift, a slug of liquid will be moving up, okay, instead of creating bubble. If you are creating bubble, so the bubbles or air or gas will be moving up, liquid will be standing there only. Okay. So, for intermittent gas lift you are not creating bubble flow, you are creating slug flow or ballistic flow here you are saying. A continuous gas lift system, steady state system, steadily continuously you are producing multi-phase flow and it is moving up, accurate fluid from bottom, near bottom to the well to the surface. Okay. IGL or intermittent gas lift system, it is unsteady flow, you are initially you are allowing accumulation of liquid, then you inject very high amount of gas, liquid slug will move up to the surface. Okay. Again stop, again you allow liquid column to build up. Okay. So, what you do, this is your standing valve, liquid column getting build up. So, on certain amount of liquid column build up, you inject high pressure gas, okay, and whole liquid will be lifted up. Then again stop for certain time the gas injection is stop. Okay. Then again liquid column will be build up, again inject gas, remove liquid column, stop again liquid column build up, inject gas. So, sequentially you are doing liquid column build up, injecting gas, this is removed, again liquid column build up, injecting gas, removed. So, that's why it is intermittent. In continuous gas lift system your gas was continuously coming to wellbore and it was going out of the wellbore. Okay. So, this is slug flow, okay, and in this case it is bubble flow. In continuous flow, in intermittent flow it is slug flow. So, you should remember. So, in continuous flow we are not creating slug flow, and again intermittent flow we are not creating bubble flow or mist flow. Okay. So, what is happening in intermittent flow? You see here, this is one tubing here, inner one tubing, okay, and you have packer here and you have this standing valve will be there and you are allowing liquid slug to build up. Okay. When liquid slug build up, it is building up to this level. Okay. Then inject gas from here, this is one gas lift valve is here. So, inject gas from here. So, gas slug is moving up, gas slug pushing the liquid up. Okay. You are not creating any bubble. So, this is slug flow, SLUG, slug is moving up. Okay. They are moving up. Okay. So, once slug gone outside, again stop the gas injection, allow column to build up, inject gas. So, intermittently you are injecting gas, okay, and you are normally the port size will be larger, amount of gas injecting that for smaller period is very high. So, that quickly you remove the liquid. If you give enough time, the liquid will be falling back. So, to avoid fall back you have to inject sufficient amount of gas so that quickly it will be moving up out of the wellbore. Okay. Otherwise a fall back problem will be there. Now, intermittent gas lift means continuously pumping one in sequentially you are pumping, gas injection going out, gas injection going out like this. Now, another technique is there to remove liquid from wellbore. This is called plunger lift system. In that case, you may or may not inject gas. Rather, reservoir whatever pressure is there, that pressure will be used to remove the liquid from wellbore. Okay. The principle is same for gas well deliquification. Basically, high gas oil ratio or gas liquid ratio. Okay. So, high gas liquid ratio means oil, very oil wellbore, very high gas is there, or gas well with low amount of liquid coming in that case. Okay. When reservoir pressure is down, in that case you remove the liquid, you get more production. Okay. So, this is called free piston free piston system. Okay. One plunger or free piston, this is called plunger. Okay. So, plunger is not connected to any surface unit or anything, it is just freely floating from bottom to top. How it works? So, what will happen, you take the plunger, the red portion you see plunger written there. So, hold at the bottom, okay, there will be one spring, bumper spring. So, bumper spring temporarily it will hold it, okay, then it will allow liquid to build up over it. Okay. Liquid will be building up here. Now, once certain amount of liquid is built up, you remove this plunger and plunger will be pushing up to the surface. How? Because the reservoir pressure is high, that pressure will be pushing the plunger up, then it will be hold at the top. top there will be one lubricator or catcher. Okay. So, that catcher will be holding the plunger, and it will allow more gas and liquid to come into wellbore from reservoir. Okay. So, when plunger is up, so wellbore pressure is lower now because all liquid is removed. So, what happened? All liquid removed, plunger is not there. So, wellbore is having very low pressure, that means PW is very low. So, PR is high, PWF low. So, your drawdown is high, fluid will be entering wellbore and you will get certain production. Then after certain time again liquid column will be starting build up. Okay. When liquid column started build up, you lift the plunger from top, it will be falling down through liquid and it will be going to the bumper spring. Hold it for certain time, allow liquid to build up over this plunger, again leave it, move it up, all the liquid over the plunger will go out. So, sequentially you do. Okay. This is also similar to like intermittent type gas lift, but in intermittent gas lift you did not use any plunger, you use only injected gas, but in this case you are not injecting gas, or you may inject gas also, but only mechanical arrangement, the plunger will be moving up and down. Okay. Efficiently removes liquid slug, they are calling slug, reduces back pressure, prolongs wellbore life, depends on energy from reservoir. Okay. So, reservoir energy is pushing your plunger up and down. Well, shots in to build pressure. Okay. When plunger on the top, lubricator that we holding there, so that time you have to shut in, so that enough pressure will be building up, again you remove, again you leave it, so the system will continue. So, here 4 cycles are there in plunger lift. One is build up part, then upstroke part, then blow down part, then downstroke part. In build up part, what is happening? You hold the plunger at the bottom, okay, allow liquid to build up over it. Let us say this is plunger, you are holding it here, the liquid will be building up here. Okay. After certain time, certain column level is done, then you leave it with a very high force, because it was held by one spring, this is called bumper spring. So, now you leave it and give some push. So, because of leaving and pushing, the whole plunger will be moving up and all liquid also will go up. Okay. So, when liquid going up, you see this picture I am drawing. So, liquid will be moving through this. Okay. So, this will happen during upstroke only. Okay. Now, in this you see this second picture, upstroke, the plunger is moving up and gas from your reservoir coming into. Okay. So, this liquid, blue color liquid, this is liquid, this blue color liquid is moving up, it will move through this, and finally upstroke to move to blow down or gas blow down stage. In blow down stage, what happens? The plunger is on the top, you hold it here for certain time. Okay. You are holding here for certain time. Now, your wellbore is not having any liquid. Okay. So, your PWF or flowing pressure is lower now, reservoir pressure higher now, drawdown higher, fluid will be entering, you are getting certain amount of production. Okay. So, fluid will be entering, you are getting certain amount of gas production, but at the same time some liquid also will be accumulating here. When liquid is getting accumulated, you leave the plunger will come, it will be sitting on this bumper spring. Okay. It will be sitting on bumper spring, again allow liquid column to build up section, phase, first phase. Okay. Again it will go to this one, leave it, fluid production will be there, hold it for certain time, again leave your plunger. So, this cycle will go on. Okay. In this way you are getting production. So, intermittent gas lift and plunger lift difference is there. Intermittent gas lift, gas pushing liquid, there is no interface between gas and liquid. So, liquid will be falling back. So, very long wellbore, say 12,000 or 14,000 feet wellbore is there. So, in that case what will happen? Liquid will be falling back, finally you will not get any liquid on the surface. So, whole liquid will be falling back. But here, because of this plunger, actually you are creating one mechanical separation between gas and liquid. So, this performance will be better. Okay. In some cases you assist with gas also. So, injected gas means from surface you inject gas as if in gas lift. So, when plunger hold at the bottom, inject gas and give some extra pressure, so that this velocity of the plunger will be very high. Okay. So, you get more efficiency of the whole system. So, whatever I explained, the same thing is written here. Okay. So, initially control valve is closed and your plunger is here, liquid column is being built up. Okay. And plunger seated on the top of the bumper spring. Okay. And gas production will be lower because a shut-in valve is closed. Okay. Surface casing pressure increase. So, all the pressure will be increasing because of reservoir is pushing everything, all the fluid in the wellbore. Okay. So, surface tubing pressure also increasing. Hydrostatic pressure of the liquid column causes okay, hydrostatic pressure H rho g, this pressure will be pushing downward. So, your entry of fluid will be very lower after certain time. So, when fluid entry is very low, so that time you leave the plunger, it will move up because of lower pressure. So, now upstroke will start. Casing pressure will be reaching to a certain desired value, then control or sales valve will be open. This is control valve or sales valve they are saying. So, this valve will be open. So, the upper pressure will be reduced because you open the valve, okay, and only lower pressure is there, reservoir pressure. So, lower pressure will be pushing the valve upward, okay, and liquid slug rises at about same speed as plunger. Why same speed? About what is written there? Actually, plunger is there and tubing is here. So, plunger and tubing, some small gap will be there, okay. So, some fluid actually be leaking back, falling back will be there. If you make tight sealing, then too much friction will be there. That is why they will be keeping certain amount of gap, so that some fluid can be leaking out, but still efficiency will be very high. Efficiency of the plunger lift system depend on amount of liquid falling back, okay, gas leaking upward. Yeah. So, when you are pushing plunger using gas, so gas will be moving through this small gap of this plunger and tubing, okay. Liquid will be trying to fall down. So, both will be giving lower efficiency, okay. If gas is not leaking, then the whole gas actually pressurizing to move up and whole liquid is going out. So, that practically does not happen because you have to give certain amount of clearance between plunger and tubing, so that friction will be lower, okay. Plunger moves upward, gas in the annular expands and enters the production tubing. Plunger reaches the surface, upstroke stage ends. When plunger will be caught at the lubricator in that area, then your upstroke stage will be finished. Now, next is blow down stage. Blow down stage means plunger on the top. Now, wellbore is very happy because they are not getting any resistance here. All fluid, gas, whatever coming, it will go. It can create mist flow also, but some liquid will be falling back, actually slowly flowing back. So, slowly falling back means PWF will be going up slowly, okay. When plunger is on the top, PW will be the minimum level, but once liquid start again developing the liquid column, PWF will be increasing. So, PR and PWF, the difference will be going down, okay. Gas velocity drops below critical lift point, liquid accumulates in the tubing. When liquid will be accumulating in the tubing, gas velocity will be slowing down. Liquid enters wellbore, gas rate drops, surface pressure flattens, okay. So, downstroke stage means control valve closed. Now, you got all the production, now you close the control valve, you allow this one to fall back, okay. Catch it for certain time, allow liquid column to build up, again release it, okay. Longer build up stage, energy waste by lifting the plunger excessively fast, increases average bottom hole pressure, okay. So, you have to optimize there whether you will want longer stage or shorter stage. Pressure and flow rate responses during plunger cycle. You see this one during build up stage, first one build up stage, then upstroke stage, then blow down stage, then downstroke stage, okay. Build up section means plunger hold at bottom and you are allowing liquid column to build up, okay. So, that time tubing pressure also going up, casing pressure also going up, okay. Then upstroke, when upstroke is happening, tubing pressure will be going down because your valve is open, the whatever liquid gas is there above the plunger, that will go out, So, the upper pressure is low. So, because of upper pressure low, your tubing pressure is going down, casing pressure also will be almost going down. Now, blow down stage, catch your plunger on the top of the system, okay. Then casing pressure will be go down little bit, but tubing pressure will be almost fixed, because at a fixed pressure wellbore is producing, okay. There is no liquid accumulation initially, but gradually it will be developing. So, gradually this pressure will be building up. Now, during downstroke, your pressure is building up in the tubing, okay. When tubing pressure higher, you will get lower production actually, tubing pressure lower, you will get higher production. So, during blow down stage actually you are getting more production, okay. GAPL, so these terms you should remember, GAPL and PAGL, so gas assisted plunger and plunger assisted gas lift. So, PAGL is continuous gas lift assisted by a continuous run plunger. GAPL, gas injection assisted plunger lift system by supplementing the reservoir drive. So, both are two different terms, so do not be confused. Okay. Intermittent gas lift in IGL plunger application. So, plunger lift application, I said that normally there will be no gas injection, again intermittent gas lift application only. So, there is no plunger. Now, people try to combine together intermittent and plunger lift application, both are intermittent gas lift application, but purely intermittent application there is no plunger, there is no interface between liquid and gas. In plunger lift application you have one interface, plunger, okay. So, plunger decreases the injection gas requirement of IGL or intermittent gas lift 30 to 70% depending on the plunger construction, depth of lift, injection gas pressure, adjustment of the injection gas volume and the well before plunger installation. So, this will improve performance, okay. Thank you very much for listening this lecture.